the curvature k of any function f of x is defined by. Consider the family of linear functions g of x is mx plus c. Question A shows that k of x is equal to 0 for this family of linear functions. So we need just substitute g of x, which is mx plus c, for f into k of x. We need derivative of g. So derivative of mx plus c is m, and the second derivative is 0 because it's a constant, and derivative of a constant is 0. So k of x becomes the absolute value of 0, which is 0, divided by 1 plus m squared to the power 3 over 2, which is 0 as required. Or instead of this, you may say that the numerator is 0, and it's very important to add that the denominator, otherwise 0 over 0, it means that function is undefined, but when 0 over some value which is not 0, the answer is 0, the numerator is 0, and the denominator is not 0, so k of x is 0 as required. The next, consider the family of quadratic functions. It is given that k of x is the derivative of k is the maximum value of k of x is denoted by k max. Question B, by solving derivative of k is 0, find the value of x where k max occurs. It's not required to justify that it's maximum. So let's consider derivative of k is 0. You can see that the fraction is 0. It's when the numerator is 0 and the denominator cannot be equal to 0. We can see that product is 0, but a cannot be 0, so 2ax plus b is 0, hence x is negative b over 2a. And determine an expression for k max, so we need the maximum value of this function, so we need just substitute this value of x for x into k. So k max is k of negative b over 2a, which is 2 times the absolute value of a, 1 plus 2ax, so 2a times negative b over 2a plus b squared and to the power of 3 over 2, so it becomes negative b plus b, which is 0, so it's 2 times the absolute value of a. The next, state the value of limit when x tends to plus infinity of k of x, and explain the significance of this result. Let's consider k of x when x is very large positive. When x is very large, this constant b is much less, so we can ignore this, and it acts like some constant divided, and also 1 is much less, so it acts like some constant divided by infinity to the power of 2 times 3 over 2, so cubed, so some constant divided by infinity cubed, it's just infinity, or constant divided by very large positive value, so the answer is very small positive value, or limit is 0, so limit when x tends to plus infinity of k of x is 0. What does it mean? It means the curvature tends to 0 when x is very large positive, and with respect to quadratic function graph is parabola, so when x is very large positive, and actually when very large by absolute value and negative, it will be absolutely the same because it's symmetrical. So this curve tends to be a straight line. So I can say that for large positive values of x, a graph over quadratic function tends to be straight line. It is given in a data booklet that, oh sorry, it is given in mark schemes that for large positive values of x, it's answer from mark schemes. Quadratic functions are close to being straight. It's my variant, it is not given in the mark schemes, and this it's the answer from mark schemes. The next, consider the quadratic functions p and q. State which statement is true and justify your answer. K max of p and k max of q should be compared. So what is k max over quadratic function from the previous? It's what? It's just 2 times the absolute value of a. So since k max is 2 times the absolute value of a, and a for p it's -2 and a for q it's 2, so and the absolute value of -2 is equal to the absolute value of 2, or you may calculate k max of p, it's what, it's 4, and or you may say that k max of p is 4 and k max of q is also 4. So C is correct. The next, consider the functions the function v of x, which is ln of x. For v it is given that k of x and derivative of k, x is greater than 0, it's domain of ln. See, I determines the exact value of x where k max occurs. And again, absolutely the same. K max when what the derivative is 0, so 1 minus 2x squared is 0, x squared is a half, and as x is positive, x is 1 over square root of 2, or it's root 2 over 2. And then shows that k max, so we need this value when x is 1 over root of 2, so k max is k over 1 over root of 2, it becomes 1 over root of 2, 1 plus 1 x squared, it's a half to the power of 3 over 2. It becomes 3 over 2 to the power of 3 over 2. It's what? It's square root of 3 over 2 cubed, and cubed it means squared, and 3 over 2 squared times 3 over 2, and 3 over 2 squared and square root is just 3 over 2. So we can say that it's 1 over root of 2, 3 over 2 times square root of 3 over 2, which is this square root of 2 and this square root of 2 they cancel, and we get that it becomes, this 2 becomes in numerator, so it's 2 over 3 times root of 3, and multiplying numerator and the denominator by root of 3, we get 2 times root of 3 over 9 as required. The next, consider the function w of x is e to the power of x. It is given that k of x and derivative of k, and absolutely the same shows that k max is. So again, the maximum value of a function arises when a derivative is 0. So ex times 1 minus 2 times e to x is 0. E to the power of x cannot be equal to 0, or there are no solutions when e to the power of x is equal to 0, because the graph looks like this. It doesn't intersect the x-axis, or if you try to apply ln, it becomes ln of 0, and due to the domain it doesn't exist at all. So 1 minus, let's write, it cannot be equal to 0, so e to 2x is a half, and you can see that we need k max, and it's not required to find x when it occurs, and you can notice that to find the maximum value of this function we need e to the power of x and e to the power of 2x, and it's not required x. So it's not required to solve for x, but we need e to the power of x, and applying the square root on both sides, it becomes that e to the power of x is 1 over square root of 2. So let's rewrite. So when derivative is equal to 0, e to the power of x is 1 over square root of 2, to be more clear. So k max is e to the power of x is 1 over root of 2 divided by 1 plus e to the power of 2x, which is a half, yes, and to the power of 3 over 2, so it becomes 1 over root of 2, 3 over 2 to the power of 3 over 2, and it's absolutely the same. So it's what? 3 over 2 times root over 3 over 2. Root of 2 cancels, and it's 2 over 3 times root of 3, and multiplying numerator and the denominator by root of 3, it becomes 2 times root of 3 over 9. And the next suggests a reason why v and w have the same maximum curvature. It's because e to the power of x and ln of x are inverse function for each other, and we know that for a function and its inverse, curves are symmetrical about a line y is x. For example, when a curve or a function looks like this, its inverse looks like this, and definitely they have same shape, so they have same values of curvature, so the maximum curvature also will be the same. So we can say the next, w and v are inverse functions of each other and graphs of W and V are symmetrical about y is x, so they have the same shape. The next. Consider a family of curves. Y is square root of r squared minus x squared, and r is a positive constant. It shows that the second derivative of y is this value, so we need just differentiate. So let's find the first derivative. So let's find dy over dx and let's differentiate this. So we should apply chain rule, and it should be considered as some function to the power of a half, as function to a half, and derivative is, chain rule says that apply the same rule as it would be x to the power of a half, so derivative is a half function to negative a half, and according to the chain rule, it must be multiplied by this function derivative, so it becomes r squared minus x squared to the power of a half. Its derivative becomes a half r squared minus x squared to the power of negative a half multiplied by r squared minus x squared, derivative which is negative 2x. R is constant, so r squared derivative is 0. Let's rewrite, as you can see 2 cancels, so it's negative x, and 2 negative a half, it becomes square root in the denominator. And to find the second derivative, we can consider, we should consider this as what? Quotient, and actually it may be considered as a product using this. And applying a quotient rule, it says that derivative is denominator squared, so just r squared minus x squared, and the numerator becomes the numerator derivative, which is negative 1 times the denominator minus numerator negative x, so plus x, multiplied by the denominator derivative, again function to the power of half, derivative is a half function to the power of negative a half, which is square root in the denominator, and multiplied by this function derivative, which is negative 2x. Let's simplify. You can see it becomes minus minus. Let's factor out minus, and the denominator becomes r squared minus x squared, it's y squared. Square root, it's what? It's y. 2 cancels, and it becomes plus, because minus is factored out, it becomes x squared over a square root, which is y, and multiplying each term in the numerator and denominator by y, or you can do what? Common denominator in the numerator and then divide two fractions. It's the same, so it becomes negative y squared, squared plus x squared over y cubed, and y squared plus x squared, you can see that it's what? It's r squared. negative r squared over y cubed as required. Hence, shows that the curvature k is constant for this family of curves. Constant, it means what we should get in terms of r only, because it's a constant. So let's consider k of x. And what is curvature? It's this expression, so we should consider this expression. Let's rewrite that it's the second derivative and the absolute value, 1 plus the first derivative squared and to the power of 3 over 2. So we need to consider this, and we should get in terms of r only. So the absolute value, let's rewrite to be more clear. The second derivative is this negative r squared over y cubed, 1 plus the first derivative. Where is it? It this, and squared, it becomes x squared over just r squared minus x squared, which is y squared. And to the power of 3 over 2. It becomes r squared over y, this is y cubed, and let's do common denominator, so y squared plus x squared to the power of 3 over 2. So it becomes y squared to the power of 3 over 2, and y squared plus x squared, it's what? Y squared plus x squared. So y squared is r squared minus x squared, so y squared plus x squared is r squared. So it's r squared and to the power of 3 over 2. And it becomes r squared. You can see that it's what? Y cubed, so y cubed cancels, and it becomes here r cubed, so it's 1 over r. And since r is positive constant, the curvature k is constant as required. And that's all for this question.